Hello, welcome to this tutorial. In this video we are going to see how to find the function, whether it is continuous or non-continuous. So we will discuss about continuity of f functions. So at the end of the class it's expected to determine the value of k if the function f of x given by this one is continuous. Okay, first let's define what is continuity. Continuity, when we define informally, we call y equal to f of x is continuous if the graph of a function is single connected curve in the plane. In principle, if we can draw without lifting the pen off the page. So continuously, if we can draw the function without lifting a pen off the page, then we call it the function is continuous. If it fails to do so, then the function is discontinuous. But this definition is the informal definition of continuity. Just some common form of discontinuity are whole, and so on. For example, jumps. As we see here, there is a jump at x equal to a, so this is one type of discontinuity which can't be removed. And the second one is whole discontinuity, or we call it removable discontinuity for this kinds of discontinuity, because we can remove discontinuity and we can make continuous. And the third type of discontinuity is infinite discontinuity. It means if we have vertical asymptote, so we can't remove that, we call it infinite discontinuity. Those are some of type of discontinuity types. Okay. Mathematically, you can find this continuity by, if a function f is continuous at x equal to a, then we mean that the limit of f of x as x approaches to a must be equal to the function at a itself. So it should satisfy. The first one is f must be defined at a, so there must be f of a must be existed, and f of a must be defined. This is the first one. And the second is this limit must be existed and it should be equal to that of a function defined at a value of a. Thus, for continuity, mathematically it should satisfy these conditions. If it satisfies this condition, then we call it is continuous functions. So it means f of a must be defined, the limit must be exist, and the value of f of a and this limit must be equal. Okay, let's do some examples. As an example, the first question is, are they continuous over real number? For example, for the first question, is it continuous for all value of x? No, because at x equal to 2, this function is not defined, because it will be x equal to 2 it is vertical asymptote. It means there is infinite discontinuity type. Thus, it is not continuous over real number. For the second case, if a function is defined as the first one, and if it is defined as 4, if x is equal to 2, then we have to check if it is continuous or not, because at x equal to 2 it is defined by another function that is a constant function 4, and if it differs from 2 then it is defined by these functions. So to check whether it is continuous or not, we have to do some calculations. Okay, the first one is g of 2 is 4, you know that, so it is defined. So the first condition is fulfilled, and we have to check the limit value. The limit value of these functions is simply x squared minus 4 over x minus 2 is the same as x minus 2 times x plus 2 over x minus 2. So x minus 2 will be x, by x minus 2 it will be cancelled, and we left with x plus 2. Thus the limit of g of x as x approaches to 2 is the same as the limit of x plus 2 as x approaches to 2, because x minus 2 will be cancelled by x minus 2. So when we substitute 2, it will be 2 plus 2, it is 4. So this 4 is the same value as of g at 2, it is 4. Thus the third condition is also fulfilled. Therefore, if this is fulfilled, then the function g of x is continuous. That's why when we have a hole, it is a type of discontinuity which can be removed. So we call it removable discontinuity, because we can remove that discontinuity by making a function defined at that discontinued point. Okay, let's do some exercises. Here the question is to find the value of a so that the functions are continuous everywhere. For the first one, for example, for these functions to be continuous, therefore it should satisfy, it is defined for x equal to negative 2. At x equal to negative 2, it is a times x. It means at negative 2 times minus 2, it will be minus 2a. It is defined. And the limit, when we say the limit, both the left and right hand side limits. For example, the left hand side limit of a function is 6. So the limit of these functions is this 6 must be equal to minus 2a. Therefore, a must be minus 3 to satisfy these conditions, the third conditions of continuity of a functions. So for the first one, f of negative 2 is minus 2a from this sentence, and the limit of f of x from minus 2 from positive side is 6, because for x greater than minus 2 the function is defined by 6. Therefore, to be continuous, both from left and right hand side limits must be equal to that of the function's definition at a point x equal to a itself. Therefore, a is simply minus 3. Okay, for the second question, the first one is to find the function if it is defined at x equal to a. So for this, at x equal to 2, it is defined by 1 plus x squared. It means when you substitute 2 squared plus 1 is 5. So it is 5 at x equal to 2. And for x less than 2, a plus x. Therefore, the limit of f of x for as x approaches to 2 from negative side is a plus x. Therefore, it means when substitute 2 plus a must be equal to that of a function at a, that is 5. Thus f of t is simply 1 plus 2 squared, which is 5, and from negative side it will be a plus 2. Thus we have to make these two equations equal. Therefore a plus 2 is equal to 5 to be continuous. Thus a equal to 3. If it is 3, these two equations are equal. That means these piecewise functions will be continuous. Okay, let's see the third question. The third question is piecewise functions given by 2x squared plus 3 for x less than or equal to 3. So at x equal to 3, it is defined by 2x squared plus 3. Therefore, when we substitute 3, it will be 2 times 3 squared plus 3. Therefore, 2 times 3 squared is 9. 2 times 9 is 18 plus 3 is 21. So at f of 3 is 21, and the limit of f of x as x approaches to 3 from positive side is 3x plus a. Substitute 3, it will be 3 times 3, 9 plus a. So 9 plus a must be equal to that of a function defined at these functions. It will be 21. So it should satisfy those two equations, and a will be equal to 12. For the last equation, for the last question, we need to find the value of a so that these functions is continuous everywhere. Therefore, to be continuous everywhere, what should be this value of a? F of a is -1 from this equation, and f from the limit of f of x as x approaches to a from negative side is defined by these functions. It means from negative side it is defined by the limit of f of x from a from negative side is defined by x squared plus 2a. It means when you substitute a, it will be a squared plus 2a, which is equal to that of this -1. So to be continuous, it should be equal to -1. Then solve for a from this equation so that this functions is continuous. Therefore, f of a is, we know it is -1, and the limit of f of x from a negative side, the left hand limit is a squared plus 2a, and to be continuous this should be satisfied. Therefore, a squared plus 2a plus 1 is equal to 0. It means a squared plus 2a plus 1 means a plus 1 the whole square equal to 0. Therefore, a is -1. So a will be -1. If a is -1, then these functions will be continuous over real number. This is the way how to check the functions whether it is continuous or not. Basically, we need to check the 3 conditions. First, we have to see if it is defined at a, and we will see if the functions have limits, and after that we will check if the limit value is equal to that of a function value at a. If it satisfies this, then we call it discontinuous. If it fails to do so, then it is discontinuous functions. Okay, for today it is enough. Goodbye.